Okay, we're going to look at the reaction of chlorine with water. So if you bubble chlorine through water, a lot of it will just dissolve and won't react. So you get Cl2. But some of it will react with the water. And it reacts to form HCl and this substance, HOCl, which is called chloric 1 acid. And the 1 Roman numeral refers to the oxidation state of the chlorine there, which you work it out, it's got an oxidation number of +1. Now, really, I should put this down as an equilibrium reaction. I'm going to do that. It's an equilibrium reaction, and the equilibrium actually lies to the left. So that means most of the chlorine just remains unreacted as diatomic chlorine dissolved in the water, and a small proportion of it reacts to form this hydrochloric acid and HOCl. Now, if we just look at what's going on there, this reaction, look at the oxidation numbers of chlorine. Right here, chlorine's got an oxidation number of 0, uncombined element. And here, well, hydrogen always +1, so the chlorine there's chloride, so it's -1, and here it's +1. So you can see that one of the chlorines has become, one of them has become reduced, and the other one has become oxidized. So this is a disproportionation reaction. Okay, there's another interesting thing about this reaction, is, well, the way it's an equilibrium reaction, but how can you push it over to the, you can quite easily push it over to the right. Okay, so if you think about this, right, what you're going to do is you're going to have H+ ions from the HCl, strong acid, and you're going to have some H+ ions from the HOCl. That's a weak acid, but some from there. So Le Chatelier tells us if we remove the H+ ions, the equilibrium will move to the right. And what's the best way of removing H+ ions? Well, that's easy. What you do is you add OH- ions, add some sodium hydroxide. And if you do that, you push the equilibrium right over to the right. And this is how bleach is made. So we can show this as a reaction. Chlorine will react with sodium hydroxide solution. I think you're going to need 2 there. And you will get sodium chloride, and you'll get sodium chlorate 1. So this is the chlorate 1 ion. The oxidation number again is 1, and you can see this is a disproportionation reaction also, because we've got chlorine 0 there, goes to -1, and it goes to +1 there. Okay, so what I'll do is I'll replace that with an equilibrium sign. But this in this case, the equilibrium lies very far over to the right. And this mixture you've got here of sodium chloride and sodium chlorate, this mixture is basically, this is household bleach. So household bleach is made by reacting chlorine, bubbling chlorine through alkali, through sodium hydroxide, and you end up with this mixture of the solution. Now, how does household bleach? It's obviously, it's antimicrobial. Why is it antimicrobial? It's because it's the chlorate 1 ion that is the active ingredient. The sodium chloride doesn't do everything, obviously, but this is a strong oxidizing agent. That will kill, oxidize the surfaces of bacteria and kill them. and damage a lot of other things. And it was also, so it's antimicrobial, and it's also bleaching. Well, what bleaching means is it will react with colored pigments and make them colorless. So they use a lot of this sort of bleach to bleach paper, so it's not sort of like a sort of grey brown color. So it's used in vast quantities for that, and it's used in large quantities for household bleach as well. So it's quite an important chemical. Right, now if you ever look on a bleach bottle label, and I've got one here, down here, it usually says, so I'll just make that bigger. Okay, so if you can see there, right, this bit here, if you can see, it says water, blah, 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 it released dangerous gases, chlorine, that bit there, okay? And if you could read the bit of the label which is out of view, it says do not mix with other cleaners, other cleaning. And the reason why they say that is because quite often other cleaning things contain acid, if you're getting rid of lime scale. Now let's have a think about what would happen if we added acid to that, to a solution of bleach. Why will it release chlorine gas? We can explain that. Go back to where are we? Okay, so this is our equation. Right, now here, if we add acid, what will that do to the OH minus? It will remove the OH minus. Le Chatelier tells us what's going to happen. If you remove OH minus, it's going to try and make OH minus. And how will it do that? The equilibrium will shift to the left. If the equilibrium shifts to the left, what do you get? You get chlorine release, chlorine gas released. Okay, and that's obviously poisonous, and you can breathe, if you breathe it in, it's very harmful. Okay, so that is what household bleach is. Okay, and it's a disproportionation reaction, a reaction between the chlorine and sodium hydroxide. There's one other little line in this specification which you should be aware of. It says chlorine reacts with water to produce oxygen. Okay, that's what it says. Right, we can explain that. Right, chlorine, we've seen before, will react with water. Equilibrium reaction. You're going to form HCl and HClO, which is chloric 1 acid. And then what happens, chloric 1 acid in the presence of UV will break down to HCl and oxygen. That's what happens there. Okay, so chlorine, if it reacts with water, yeah, it will produce the HCl there, but it will produce that, and then that decomposes to form HCl and O2. Just before we finish, let's have a think about what's happening in oxidation and reduction, that reaction. Well, the chlorine has got an oxidation number of +1 there, and here it's got an oxidation number of -1. So the chlorine has become reduced. Now the oxygen here is -2. Oxygen is always -2 in its compounds, but here it's 0. So the oxygen has become oxidized and the chlorine has become reduced. That is a redox reaction. Okay, so that's all we need to know about the reaction of chlorine with water or with alkali.